Hello and welcome back. We are continuing our long series of taking a look at electronics components, and today we are looking at diodes. And I'm sure you already know what a diode is, but here's a physical diode, what it looks like. This one is a through-hole component because it can go into a through-hole PCB, and that's why it has these legs. And basically a diode is consider it like a valve that works only in one direction. So it lets current flow in one direction but not in the other. It's like a blocking device. So which is why they always have a polarity. Most diodes will have a band that indicates what's known as a cathode, and the other end is obviously then the anode. So the higher potential goes on the anode side, and the lower potential comes out on the cathode side. So if you want, let me turn it around like so. So that's, I use the pen. So that's the symbol for a diode. That's anode. That's K for cathode. Usually that's how we write it. This is historical. And current will flow from anode to cathode, but it won't flow from cathode to anode. So it's used for regulating current, for protecting devices, and a whole bunch of applications. You really find them everywhere in electronics. Let me show you a few. Here's that circuit that we've been taking a look at often, and you'll notice that there's a whole bunch of diodes here. These are 4 diodes, and by looking at it I know that these are forming what's known as a bridge rectifier, where these 4 are connected in a bridge configuration, and they receive alternating voltage as an input, and on the output side you get what's known as rectified alternating current, which means you don't have the negative transition. The transitions are always on the positive side. And then there's a whole bunch of diodes at other locations in the circuit, which are used mostly for protective functions and stuff like that. There's another one here at the end. Here's another circuit, and you'll notice this big square block. There's also actually a diode. This is what's known as the bridge rectifier, and this has 4 diodes inside it and 4 pins, and it is similar to these 4 diodes that are formed here. So instead of installing 4 separate components and soldering 8 pins, you just install this one block and you have 4 pins, and it makes for a more neater, more easier production process and so on. And you'll notice that it's marked with plus and minus. So that's the output, the positive side and the negative side. And these sine wave symbols here, where you have the sine wave or the AC input. This one is also a bridge rectifier, same as this, different package, different shape, but it also has the 4 pins. This one marked plus is positive, so the opposite side is negative, and then these 2 are the AC input pins. So there's another diode for protection, and essentially if you look at any circuit, you'll find so many of them. Here's our arcade circuit, and you'll notice there's another diode here, which we are using for battery polarity protection. So if you connect the battery in the wrong polarity, the circuit won't work, and you won't lose any of the magic smoke. The diode is going to protect you from burning up the components. There's also a second one here, which is used as a protective function. So this diode is connected across the audio buzzer, and the purpose of the diode in this condition is to protect or make sure that the transistor which is driving the buzzer doesn't get damaged. And this kind of application you'll find most often when you have a transistor that's operating a relay or a big load and stuff like that. It's also interesting to note that this is the Atmega chip on your Arduino Nano, and inside it, on every GPIO pin, you have lots and lots of diodes. These are known as parasitic diodes, and they basically connect each GPIO pin to the positive rail and to ground, and these are formed out of the production process that is used, and in a way they help protect the digital pin to some extent, for sure. So yeah, let's look at a couple of these common types of diodes. This is the symbol for it. The black one you've already seen what I've shown you here, but you also get little glass encapsulated diodes like these. Usually the glass ones use material what's known as germanium. It's not commonly used nowadays in most other semiconductors besides these kinds of diodes, and the black ones are usually silicon diodes. And this is how it works. If you have an AC supply or an input and you put a diode in series with that supply, what you get on the load at the output is basically unidirectional voltage or current. So the negative transition of the sine wave is blocked because that's the reverse polarity for the diode, and it doesn't allow current to flow in that reverse direction, but in the forward direction it conducts. So you get these positive transitions, then you have a gap, then you have the next positive transition and a gap, and so on. So this is like the rectified output, and that's the AC input. And this is how it goes. You have the AC input going into the diode, and then on the output it just passes the positive half cycle of the AC. And looking at it a little bit more deeper, this is the bridge formation that we talked about. I showed you a couple of bridge rectifier diodes in configurations. So the 4 diodes are connected in this fashion. You have the AC coming in here and the AC coming in here, and then this point is where the positive output is, this point is where the negative output is. So it's interesting because there's a couple of very useful components being used here. One is the transformer, which is essentially an inductor. Right? So this will usually convert, let's say, a voltage such as 230 volts to a lower, safer voltage like 12 volts. And because the 2 coil windings are sort of isolated, they are not connected to each other physically. I wouldn't say physically because they are connected physically, it's part of the same transformer, but they aren't connected electrically. They are coupled through a magnetic process. So the output is safe to touch compared to the input, which is 230 volts. So if you touch here, you'll get a shock, you'll die. But on the output side, if it's 12 volts, because it's not connected to the 230 volt supply in any direct fashion, it is safe to touch. And the voltage at this position would be a sine wave like this that goes on over time. Now, when you give that as an input to the rectifier, what you get at the output of the rectifier, which is this top connection over here, is this rectified AC voltage, which is basically the same sine wave, but in this case, even the negative transition is converted to the positive direction. Now, this is kind of not very useful for us if we are trying to get what's, let's say, direct voltage or DC to power a circuit, let's say a nano or an ESP32. So we have to smoothen out this voltage. And that's where the capacitor comes in that we talked about earlier. This is the filter capacitor, and its purpose is that when the voltage rises, it stores charge inside itself, and then as the voltage decreases, that charge continues to provide current to the circuit until it discharges. But by then, the next cycle of your AC has started, so it charges up again. So what you get is this a little bit of a fluctuating DC over here. This variation is not a lot and can be used for some simple electronics applications, but it's still not a perfect DC. There is a slight variation in every cycle as it charges and discharges over time. So then you give that as an input to a voltage regulator, whose purpose is then to smoothen out and make sure that you get a really nice, clean, direct voltage output. So that's a look at some of the components that we've already looked at in our past sessions up until now. You will also have additional capacitors on the output for the same purposes as smoothing and filtering. So that's again a very quick dive into diodes and what they are. They are very useful devices, and it's good to know how they work. I'll see you around the next time.